the class bell run. So let's continue. Continue. Okay. Yeah. So something happened in the after class that you talk. Yeah, I want to join. If you have some interesting things, share it. Okay, share it.
We're speaking Chinese.
Yeah, Chinese is a good choice. Okay, continue. Yeah, the figures. Yeah, figures I post here is that this one is the cubic, and this one is the prism compressive strength, and that they draw the line, right? They draw the line and build use this formula to build these two strengths, the relationship. Okay. Okay. The next we will talk about axial tensile strength, FT. Remember these symbols, okay? For the tensile strength, because the tensile, we know, because microscope view, because before I showed there are some small, really small, the crack already exist between the gravel and the cement, right? Cement. Because it's under the load, only the minimum, the small crack developed, they form the large, the crack, right? Crack. The force will affect the crack direction. Yeah, the direction. And for here, the tensile strength, we already know the concrete had a weak in the tensile. They had a good in the compressive. But we also need to know, the tensile strength and how we get this tensile strength. Okay, look at here. Because the crack deformation, the tensile strength. When the crack under the load, they failed, they had a crack, they had torsion, these things will related to the tensile strength. So we need to know the tensile strength, right? So it's a basic mechanical property. So how we use this specimen. Okay, look at here. The specimen size. Look at here. The total is the 500 millimeters. Okay, 500 millimeters, and the section size is the 100 and 100. And there we use a steel bar to embed it, right? Embed it in the concrete. And in the material mechanics, do the teachers tell you the 圣维南 sandwich principle? Did he mention this concept or not? The sandwich principle. The sandwich principle can, I can roughly to say it here. Sandwich. In Chinese, it's named 圣维南原理。圣维南。Chinese is the 圣维南。Just translate from the English, right? Not here. Principle. 圣维南原理。Okay, how the sandwich principle, what does the sandwich principle? That means because the boundary, the different, because in reality, sometimes we can regard it as the hinge, right? Hinge. and some fixed. We can choose the different boundary, right? Boundary, but they only affect. They will affect this part, the stress state. They will do not affect this part. Yeah, that's the sandwich principle. Look at here. You look at here. This is the spaceman. We use the steel bar embedded in the spaceman. Also, give it the force, right? The tensile, the tension. We know in there the stress will parallel, but we also the spaceman. We use a machine to touch the here to give it the tension. Yeah, tension. In this part, they also the parallel, but in the boundary stress state at here, this is totally complicated, right? The things, yeah, just imagine, this is the steel bars, we give it at here, the force will transfer to this part, the shape, the stress weight, stress pace will look like this. And here so we use a 夹子 to give it a tension. Yeah. Okay. Look like this is the specimen. I use like you can imagine there the machine look like this. Look my hand. They give it the tension, right? And also there's the steel bar embedded in here. I just give the force from the steel bars. They also will give the spaceman the tension. Right? Yeah. These two ways give the spaceman the tension. Only the difference is between the boundary part. Yeah, near the boundary part. They will do not affect the middle part. Okay, and the distance about this effect is about h b. This the side of b is 3b. 3b. Yeah. If you're curious about the sandwich principle, you can search it from the internet. Maybe in Chinese I can explain well, but in English I may be hard. But I think some students may get my point. Like the tension. Yeah, to this tension test, to the direct tension stent. I want to show that use the steel bars embedded spaceman give the tension, and it directly give the tension. Yeah. They only affect in there the things will be different, and in the middle part they are the same. Sandwich principle. Sandwich principle. I will practice English and later to tell you exactly. So the knowledge of the science is really interesting. They have a lot of principles. These principles can help us easily to explain something. Yeah, and then we'll continue. And here we use the steel bar embedded in the spaceman. And then give the tension, right? Give the tension. Okay, look at here. That's the y, and in this one, minus, there's a 200. 200. And we think in this part, they affected about this one is 100. The ratio only 1.5. And the crack will develop in the middle, right? In the middle. And then if the specimen broke, the field we know the value at use this value at the concrete, the tensile strength, right? We do the test and get the value from the machine, and then use this value at the concrete, the tensile stress, right? And what else is another way to take test to do the measure is about split cubic test. From this test, we easily can get a cubic, right? Cubic is the same with same as the cubic compressive test. Only different is in the compression compressive test, there's a no, you will do not put like the yellow one. This is the steel bars on the surface. For compressive strength, we do the test. We will let the machine touch the surface, but in here we use the steel bar. Just you can imagine this is the scissors. They apply the force on the cubic, right? So it gives give force on the specimen, and in this specimen here, we drew the stress state line here. In this part, look at this part, the concrete under the press. But in the middle part, they under the pool. Just like soil, you can imagine soil. We give you can imagine the cubic is really soft, and if we give the force in here, it will have the transverse deformation under the load. So in the middle part, they just like have the tension, just like there's a tension, because we as material, they have deformation. They depend on the stress. We just give the same stress state. They will have this directions deformation. So we give this type load in the middle part. They have the transverse deformation, means the middle part they're under the tension state. I introduce here only let you know there's a different ways that we can compare specimen in the tensile stress state. And here is the split cubic test. You can imagine just this is a really soft material. We give this direction force, and in this direction, in this direction, they will have a transverse deformation. That means the material in this transverse direction, they under the tension. They under the tension. Someone also use the cylinders. The same. This is the metal steel bar. under the machine. They give it the load just like a scissors to cut the specimen. Mm-hmm.
So the sandwich you talked about, sorry for that one. It doesn't apply to this.
Sorry?
The sandwich you talked about.
Sandwich principle. No. Here, sandwich principles only stop at here, and is finished. And for tensile strength, right? Tensile strength, how we get the tensile strength? One way is we use this specimen to do directly the tensile test to get the tensile strength. And another way, because sometimes it's hard to get this specimen, but for the cubic, it's easily because they have the mode, they are the same, right? How to use this cubic specimen to test tensile stress? We use the fluid cubic test. It also can help us to get tensile stress, right? This tensile stress, okay, later I will see this. This tensile stress maybe you the FST, right? FST. T is mean the tensile. S means this is the split cubic test. And before, right? There's only the FT, right? FT. And later, this is split. Use the beam to get the tensile strength. And there is a relationship. Right? Relationship. Here, use different tests, because sometimes they have no machine or for us to do the like the axial tensile test. So we can choose another way. If just we put the specimen on the same condition, we can compare, right? We can compare the strength values, right? Okay, I can speak slowly. Yeah, do you know here? In here, I think a student can understand, right? Can understand. We use this one directly to get the tensile strength. But this direct tensile strength. At first, we need to build this specimen, right? Specimen. But sometimes you should remember there's no condition for us to build this specimen. So we need to choose another way to compare, to know the concrete strength, concrete tensile strength here. 就在这里，就是人们可以直接用这个方法得到混凝土的抗拉强度，但是在其他情况下，我们不能够通过这种方式的时候 ，we can use this way。
我们明白
了。
对呀。
就是这种方法和那种方法都可以。对，这是一种方法，去获得这个强度，就抗拉强度。然后，
所以说知识和知识不一样。
念这个是为难原理。Yeah, this sandwich principle only to explain why we use here. This is the 就这里是 the steel bar embedded in the specimen, right? But how we give the specimen the tensile, we can choose this way. We also can directly to use some hand to give the specimen the tensile. Yeah, they can have the same 效果。效果就是用手可以直接拉，也可以用机器给它那种拉力，但是呢，它这个边界上的一些情况会比较复杂。
Yes.
Yeah, if you can understand the sandwich principle, just forget it. Okay, that will not affect you to understand this part. And why I mentioned the sandwich principle, just to give you something about why does use this way, steel bar, this way to give the tensile to the specimen. Why we do not use the hand? Because the hand sometimes we do not easily control, but use the steel bar embedded, it may easy to control the force or matters to do the standard specimen. Yeah, okay. Good. Yeah, okay. Yeah, and okay, for this part, and we will continue about in here. I introduce another test can for us to compare the tensile stress, because we do not get this specimen, and we only have the cubic and the compressive machine, compression test machine. But we also can use this machine. We only put a mental steel bar on the cubic specimen and give it force, just like scissors. Yeah, scissors. Yeah, scissors. Yeah, understand? Yeah. Okay. Understand? Use the cubic, right, to do the test. Then we can get, we get a tensile stress value from this type test. Yeah. This type. And this is the cylinder specimen, right? Cylinder. And then we use this formula. For this one is for cubic specimen, and for this one is for cylinder specimen. And then use this formula and get the tensile stress, the FST, from this type test. Yeah, look at here. This is the cylinder, right? Cylinder. Use the mental bars, just like scissor. Apply force on the specimen. Yeah, and we built the relationship with the axial tensile stress and with the split cubic test relationship. The formula is listed here. They do not like linear, right? They do not like linear. They is a curve, a non-linear curve. The relation between the cubic compressive stress and axial tensile stress. Here is the cubic and the tensile stress. So not about the split cubic test with the axial tensile stress. Here is the compression. Okay. And here's just a true tensile stress, right? Tensile stress. And another way we can get the tensile stress is use a beam, right? For beam, I think everyone easily understands. For we easily get the moment, the diagram. In this part, this part, under the moment. And there's no other force. And in the section, the stress, this here is the compression, right? Compression. And this is the intention, right? Yeah, this is the intention. So we, from this test, we also can compare the tension strength. Tension strength. We give the load, and if there's a crack happen, okay, stop, and write the values, and then from according to the formula, this formula to know the tension strength, and from here we get 3 tension stress. Tension stress. One is the FT. FT is we get this tension stress directly from the axial tension stress. Use a steel bar embedded in spaceman and do it. Give the tension force to measure the concrete tension stress. And for ST, FST is the cubic split cubic test. We get this tension stress. You can imagine just like scissors in the to do the tension stress. And the FR is the rupture modulus. It's the tension stress. We get it from the beam, and from the calculation. And these 3, they have the relations, right? Relations. But we can compare it. Only the same conditions we can compare it different. The tension stress. You know, the grade of C30 is larger than C. C30 is the tension of the C30. Larger than of tension C20, right? And the FST, we can compare the different grade of the concrete in the same test. Right? We can compare. And also for different test, they also have these relations. Okay. For now, yeah. I summarize it. Okay, summarize it to easily to understand. For concrete, the important important strength we need to know is the cubic compressive and prism compressive strength and the tensile strength. This is the 3 important strengths about the relative to the concrete we need to know. Yeah. This is 3. And for cubic compressive stress, we know the test process easily. Easily use the cubic and do the test. And also for the prism compressive stress, we know the height. The height should be 3 times than the width. And because of the friction effect, the value is smaller than the cubic compressive stress. This is about compressive stress. Okay. And for the tensile stress, we can use 3 tests, 3 totally different measure ways to compare. One is the axial tension test. And then from this test, we get axial tension strength. And another is the split cubic test. For this test, we just like scissors give the force to the cubic, we get tensile stress, FST. And the third, we use the beam. We compare the beam specimen and do the test. The rupture modulus, and these three tension strength have their own relations. Here I show you some videos about.
Split tensile strength test on concrete. In the split tensile strength test, the tensile strength of concrete is obtained by applying a compressive force along the length of the concrete cylinder. The specimen used for this method is of cylindrical in size and dimensions of 150 mm in diameter and 300 mm in length. The instrument used for this method is the universal testing machine. The specimen is prepared in the standard manufacturing procedure and placed on the mold in layers and tamped using 25 blows for each layer. After a day, the mold is removed and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 7, 14 and 28 days for testing. Draw the line on the specimens as displayed on the screen. Then, record the weight and dimension of the specimen. The specimen is placed longitudinally in the machine. A bearing strip made up of plywood is placed on both sides of the specimen and align it according to the marking. Sometimes, supplement bars are placed on top of the plywood depending upon the diameter of the specimen. Now, apply the load continuously at a rate within the range 1.2 to 2.4 MPa per minute. Finally, note down the load at which cylinder fails by developing cracks. The resultant split tensile strength is calculated by the equation 2P divided by phi into D into L, where P is equal to load at which the specimen breaks. Thank you for watching. Stay tuned. The best is yet to come. Split tensile strength test on concrete. In the split tensile strength test, the tensile strength of concrete is obtained by applying a compressive force along the length of the concrete cylinder. The specimen used for this method is of cylindrical in size and dimensions of 150 mm in diameter and 300 mm in length. The instrument used for this method is the universal testing machine. The specimen is prepared in the standard manufacturing procedure and placed on the mold in layers and tamped using 25 blows for.
This is the video about split. This is the cylinder, not cubic, but the cubic is the thin, right? Thin. Just we get the specimen from the mold, and they had the standard process like humidity, temperature, and nitrogen, and the machine is the universal testing machine. Here is the hallway wood, right? Hallway, that's a steel, metal steel bars. Okay, let's watch another. How to determine the
compressive strength test on concrete.
Yeah, this is about compressive stress. the tubing.
The compressive strength of a concrete is defined as the ability of the concrete to withstand specific compressive forces. Compressive strength of concrete depends on many factors such as water-cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Generally, the specimens shaped in cube and cylinder are used for testing the compressive strength of concrete. The standard size of a cubical specimen is 150 mm into 150 mm into 150 mm, while the cylindrical specimen is 150 mm in diameter and 300 mm in length. Generally, the fresh concrete is prepared according to the required grades and the respective mix proportion. Once the fresh concrete is prepared, the inner surface of the mold is greased to avoid sticking of concrete. The prepared fresh concrete is then filled in mold in 4 layers. After filling each layer, tamping should be done for 35 times for cube and 25 times for cylinder using a standard tamping rod. Once the mold is filled, level of the top surface with a trowel. After a day, the mold is removed and the specimens are dropped into the curing tank at a standard temperature of 27 plus or minus 2 degrees Celsius. After 7 days, the specimen is taken out of curing tank and dried for a while. Then, the specimen is placed on the compression testing machine. The cube specimen is just placed on the bearing plate, while for cylindrical specimen, it is placed vertically. The instrument is adjusted such that the plate touches the top surface of the specimen. The load is applied gradually over the specimen at the rate of 140 kg per centimeter square per minute. The load at which the specimen fails is noted. Thus, the characteristic compressive strength is calculated from the ratio of load and the area. The test is generally done with the help of 3 specimens and tested for 7 days, 14 days and 28 days. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share.
Yeah, I found this video from the YouTube and
Win.
and this video a vivid way to show how we get the different type of strengths, right, about concrete, like the compressive strength and the tensile strength. And here, there's another.
Flexural strength test on concrete. The flexural strength of concrete is an indirect method for measuring the tensile strength of concrete.
How to use the beam.
The test is made on the beam of size 150 mm into 150 mm into 700 mm or 100 mm into 100 mm into 500 mm. Flexural strength of concrete is determined by either central point loading or 2-point loading. The typical machine used for this test is shown on the screen. The bed of the testing machine is provided with 2 steel rollers of 38 mm in diameter. The rollers is mounted at the distance from center to center is 600 mm for 150 mm specimens and 400 mm for 100 mm specimens. The load applied through similar roller mounted at the top. In case of 2-point loading, the rollers are spaced at 200 cm or 133 cm center to center. The concrete is prepared as per required grade of concrete and placed on the mold in layers and dumped 25 blows for each layer. After a day, the mold is removed and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 14 and 28 days for testing. The specimen is placed on the rollers and centered with the longitudinal axis of the specimen. The load is applied at a rate of loading of 400 kg per minute for the 150 mm specimens and at a rate of 180 kg per minute for the 100 mm specimens. Finally, note down the load at which cylinder fails by developing cracks. Now, measure the distance between the line of fracture and the nearest support. Consider this as A. If A is greater than 200 mm for 150 mm and 130 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fp, is calculated by equation. Fp is equal to P into L divided by Bd square.
1 point
If P is less than 200 mm and greater than 170 mm for 150 mm and less than 133 mm and greater than 110 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fp, is calculated by equation. Fp is equal to 3Pa divided by Bd square, where B is the width of the beam in millimeters, D is the failure point depth in millimeters, L is the supported length in millimeters, P is the maximum load applied to the beam in kilograms, and is the distance between the line of fracture and nearest support in millimeter. Thank you for watching. Stay tuned. The best is yet to come.
This formula I have to see. It's for the 1 point test. Before I mentioned it 2 point. Okay, this class is over. Thank you.
Nas.